Good morning, dear students, and welcome back to our today's online session. We are studying about study of gas laws, where we have already learned about Boyle's law and Charles' law. And according to your new reduced syllabus, the only topic which is left to understand is the gas equation. So without doing any delay, we will start our today's class. Before starting our today's class, I'd like to inform you that according to new reduced syllabus, you don't need to study the last chapter, chapter number 8, which is atmospheric pollution. I'll be giving you the details of reduced syllabus in today's upload. The gas equation. So let us start today's class. This gas equation is an equation which tells us about the relationship between pressure, volume, and temperature all at the same time. I hope you remember the two gases equation, Boyle's law and Charles' law. They talk about relation of only two variables, either pressure with volume or volume with temperature. They do not give us relation between all these three variables. Okay, now this gas equation tells us about the relation between all these three variables. How does it tell us? If both pressure and temperature of a fixed mass of gas are varied, that means both pressure and temperature of a fixed mass of gas are changed together, then a combination of Boyle's and Charles' law gives us a fixed relation amongst its volume, pressure, and temperature. So when the pressure and temperature both are changed at the same time, then how do we get relation between pressure, volume, and temperature all at the same time? By combining Boyle's law and Charles' law. Is that clear? And that expression is known as gases equation. So let us see how we get that equation. Now, according to Boyle's law, we have volume is inversely related to pressure. Here temperature remains constant. And according to Charles' law, we have volume is directly proportional to temperature when pressure remains constant. So in Boyle's law, temperature remains constant, we get relation of volume and pressure. According to Charles' law, when pressure is kept constant, we get a relation between volume and temperature. Now, when both pressure and temperature are varied, what do we get now? We get that on combining the two laws, volume of a given mass of gas varies inversely with pressure, which is according to Boyle's law, and directly with absolute temperature, which is according to Charles' law. And how do we write that mathematically? Volume inversely proportional to 1 by P into directly proportional to T. So here, according to Charles' law, temperature is directly proportional, so T will be in the numerator, and according to Boyle's law, volume is inversely proportional to pressure and pressure is in the denominator, so here volume is proportional to 1 by P into T. So this is the combination of Boyle's law and Charles' law. Now if we remove the proportionality, then we have to write constant. So V equals to T by P into constant. T is in the numerator and pressure comes to the denominator, and we get a constant which is a constant of proportionality. Or when we rearrange this, we get PV. So if we rearrange this, the product of pressure and volume divided by temperature is a constant. So PV by T is equal to constant, and this is what is given by gas equation, the relation of pressure, volume, and temperature. Okay, how they are related? When the pressure and volume are multiplied, the product of pressure and volume, and if the product is divided by temperature, then we get a constant value. Okay, so now PV by T is a constant, we know this now. Now if the volume of a given mass of gas changes from V1 to V2, that means here volume is varying. Initial volume V1 changes to final volume V2. If its pressure also changes from P1 to P2, okay, here pressure is also now varying, and its temperature also changes from T1 to T2. So here all the three variables are varying. Okay, so according to this gases laws, what do we get now? The product of T1 V1 divided by T1 is equal to product of P2 V2 divided by T2, and which is a constant. So according to gas equation, P1 V1 by T1 is equal to P2 V2 by T2, which is always a constant, and we can write this as P1 V1 by T1 is equal to P2 V2 by T2, and we can keep on continuing, like P1 V1 by T1 equals to P2 V2 by T2 equals to P3 V3 by T3, or P4 V4 by T4. So it can go on and go on, because it is the product of P1 V1 divided by T1 is always a constant. And this particular relation, P1 V1 by T1 equals to P2 V2 by T2, this equation is known as gas equation. And this equation is used in calculating changes in gas volume when both its pressure and temperature changes at the same time. Is that clear, boys? So this equation is very important equation if you want to calculate the relation between pressure, volume and temperature varying all together at the same time. So let us see how we can use this, bring this equation into application. A given mass of gas occupies 572 centimeter cube at 13 degrees Celsius and 725 millimeter mercury pressure. So here we have three variables: volume, which is 572 centimeter cube, temperature 13 degrees Celsius, and pressure 725 millimeter mercury pressure. What will be its volume at 24 degrees Celsius? So here, if you notice, temperature is changing, and 792 millimeter Hg pressure. So here pressure is also changing. So here temperature has been changed from 13 degree to 24 degrees Celsius. Pressure has also changed from 725 millimeter mercury to 792 millimeter mercury. And finally, we know according to gas equation, volume will also change, and that changed volume we have to find. So let us start solving this numerical. Now P1, first write the given quantities. P1 is 725 millimeter mercury, P2 is 792 millimeter of mercury. T1 is 13 degrees Celsius, and we always use absolute scale, so we have to convert this Celsius temperature into Kelvin scale, which is 273 plus 13 equals to 286 Kelvin. In the same way, T2 is 24 degrees Celsius, and when we convert this into Kelvin scale, we get 297 Kelvin. V1 is given, which is 572 centimeter cube. Now we have to find V2. So let us use gas equation. Applying gas equation, what do we get? P1 V1 by T1 equals to P2 V2 by T2. Now we need V2, so we'll rearrange this, and when we rearrange, we get V2 equals to P1 V1 into T2 divided by P2 into T1. Okay, so this is the modified form of gas equation. Now just substitute the values of P1 V1 T2 and P2 and T1. We get 725 into 572 into 297, which is T2, divided by 792 P2 into 286. And when we solve this particular equation, we get the value 543.75 centimeter cube, which is the required final volume. Hence we can write the required volume of gas is 543.75 centimeter cube. Solving these type of numerical is very easy, provided you know what you have to do. And please always write the given conditions correctly. Do not mess with writing like P2's value for P1, P1's value for P2, or T1's value for T2 and T2's value for T1. Always write the given values properly. Therefore, in the beginning only, please write this given conditions at the top. So this is how we solve numericals based on gas equation. Now, based on today's class, we are going to have one assignment number 5, where you have to solve 2 numericals. So these are the questions of which answers are also provided to you, so that you can verify your answers. Do this numericals, solve it, and send it to me in time, so that timely review is done and you get your marks correctly. This much for today, boys. In our next class, we'll study about the effect of water vapor present in the atmosphere in this particular numericals. This much for today, boys. Till we meet next time, stay safe and do all things well.